Hello everyone. In this video I'm going to show you how we can solve a quadratic in general form. By solving I mean finding x or x's such that ax squared plus bx plus c equals 0, and such an x we call it a root or a zero of this quadratic. And then I will show you how we can use these roots or zeros to factor a quadratic in general form. Before that, I would like to write ax squared plus bx plus c in another form by completing a square, right? And this will be written as a times x squared plus b over ax plus c over a. I just factor a from this quadratic, and then according to what you know for the perfect square technique, completing a square, it can be written as x squared plus b over a, and then you need to look at the coefficient of x, make it half, raise it to the power of 2, add and subtract. So basically we have half of b over a is b over 2a, raise it to the power of 2, you have b squared over 4a squared. And subtract it, b squared over 4a squared, and then add the last term, which is c over a. I didn't change anything, just I add two things and I add and subtract two equal things. Okay, now if you look at the first three terms here, then by using the perfect square identity, it is nothing but x plus b over 2a to the power of 2. And in the second term, if you add, it's two simple fraction. If you add them together, then you will have 4a squared minus b squared plus 4ac. Okay, now what I can do is writing again ax squared plus bx plus c as a times, instead of these three terms I can write x plus b over 2a to the power of 2, and then take a negative from this part. I will have minus b squared plus minus 4ac over 4a squared. Now for simplicity, let me call this one delta, okay? And people call it discriminant. So basically what we did up to now is simply any ax squared plus bx plus c can be written as a times x plus b over 2a to the power of 2 minus delta over 4a squared. This is an excellent way of looking at a quadratic function. This is a quadratic, and this one exactly the same as that one, but with another format. This new format helps us a lot to find the zeros of a quadratic. For example, if I want to find ax squared plus bx plus c equals 0, then I can write this one equals 0. Therefore, I can write a times x plus b over 2a to the 2 minus delta over 4a squared equals 0. And since this is not 0, for sure I must have the square bracket things equal 0. Therefore, I have x plus b over 2a to the power of 2 minus delta over 4a squared equals 0. And now you know the rest of the work is simply by moving this part to the right hand side and taking the square root from both sides, then you have x plus b over 2a is equal plus minus a square root of delta over a square root of 4a squared, which is 2a. So x can be written as minus b over 2a plus minus a square root of delta over 2a. And it is better to write it like separately, like x1 is equal minus b minus a square root of delta over 2a, and x2 equal minus b plus a square root of delta over 2a. But here, please be careful. If delta, which is this guy here, which is b squared minus 4ac, if it is not positive, then I cannot write a square root of it. Therefore, here I assume that delta is positive. Otherwise, I cannot, positive or non-negative, I cannot take a square root of it. So, and this observation will help us a lot to complete this discussion. So ax squared plus bx plus c equals 0 has two roots x1 and x2 if delta, which is b squared minus 4ac, is greater than 0. 2 has one root x1 equal x2 equal minus b over 2a, because if delta is 0, this will be vanished, this will be vanished, and then x1 and x2 are the same, and you will get minus b over 2a if delta is equal 0. And finally, has no root if delta is negative. So basically, you can judge whether a quadratic has a solution, or has two solutions, has one solution, or has no solution, simply by knowing a, b, c, and delta, which is b squared minus 4ac. Now let me use these roots, as I said earlier, to find a factor of this quadratic. Okay, before going that, I would like you to see x1 plus x2 is what, and x1 is what. x1 plus x2 is minus b minus a square root of delta over 2a plus minus b plus a square root of delta over 2a. Therefore, it is 2a. And then add the numerator together, minus 2b and minus square root of delta plus a square root of delta will be cancelled. Then you have minus 2b. So minus 2b over 2b, these two cancelled, and then you have minus b over a. The same story for x1, x2. It is minus b minus a square root of delta over 2a times minus b plus a square root of delta over 2a. In the numerator, you have 4a squared. In the denominator, you have 4a squared. For the numerator, you can use conjugate identity to write it like b squared minus delta. And then, because delta is minus b squared minus b squared minus 4ac, the delta over 4ac. I'm sorry, 4a squared. And simplify this fraction, this b squared with this minus b squared will be gone, and then 4ac over 4a squared. 4ac over 4a squared. And this is c over a. Therefore, in short, we could find and prove that x1 plus x2 is minus b over 2a, minus b over a, and x1, x2 will be c over a. Without solving quadratic, actually, you can access to the sum and product of the roots directly from here. Okay, now let's see how we can use this information to factor a quadratic in general form. First of all, I would like you to understand that y(a)x squared plus bx plus c is equal to a times x minus x1, x minus x2. This is very easy task to accomplish. It is not difficult because if you look at the right hand side of this equation, a x minus x1 times x minus x2, then if you multiply this parenthesis over the first parenthesis over the second parenthesis, you will get a x squared minus x1 plus x2 times x, and finally plus x1 x2. Okay, now instead of x1 and x plus x2, I can put minus b over a. Therefore, I will get x squared minus b over a, which is b over a times x, and finally plus x1, x2, which is c over a. And now if you multiply this by a, you end up with ax squared plus bx plus c. Okay, this is an excellent observation. This equal to this. This is what I needed. If you give me ax squared plus bx plus c and ask me to factor it, then I factor it like this. I go and find x1, I find x2, and then put it here. Ax minus x1 times x minus x2. And if I fail to find x1, x2, it means that I cannot factor this quadratic. Therefore, you can say that if delta is greater than equal 0, then ax squared plus bx plus c can be factored. Exactly like here. If delta is negative, no solution. No solution means no 0, no roots, and therefore no factor. So basically, to make a story short, if you give me a quadratic like ax squared plus bx plus c, and if you want me to factor it, first of all, the first step is to look at the delta. If delta is positive, I continue. If delta is negative, I stop. And when a delta is greater than equal 0, I will find x1 and x2 and then use this formula, simple formula, to factor it. That's it, that's all. So let me now give you some example. Remember, I gave you one example and I told you that using sum and product is not an excellent way to factor a quadratic, even if the factorization possible, it may not be an easy task. For example, x squared plus 4x minus 1. I want to factor it. But using sum and product, forget it. You cannot do that. It is really difficult to find this two numbers like m and n that the sum is 4, product is minus 1. But now let's use it with our today technique. A is 1, B is 4, C is minus 1. The first step, find delta. Delta is b squared minus 4ac. Therefore, now you can see b squared, it is 16, minus 4ac. AC become minus 1, minus 4ac is plus 4, so it is 20. It is greater than 0, then I'm pretty sure there are two roots and I can factor it. The second step is to find the roots. x1 and x2 will be minus b plus minus a square root of delta over 2a. Okay, then let me write in one format for now. Minus b, it is minus 4 plus minus a square root of 20 over a square root over 2a, which is 2. But a square root of 20 can be simplified to a square root of 4 times 5 over 2a, which is 2. This 4 goes out as 2, and then that 2 with this 4 with this 2 will be simplified to minus 2 plus minus a square root of 5, right? So x1 will be minus 2 minus a square root of 5, and x2 will be minus 2 plus a square root of 5. I have two roots, and now I can write x squared plus 4x minus 1 as a times a is 1 times x minus x1, which is here, minus 2 minus 5, which is plus 2 plus a square root of 5, times x minus x2, which is x plus 2 minus a square root of 5. Again, you see, this is exactly your m, and this is your n. Can you see that? M plus n is really equal to 4, which makes sense. It is here. And mn, it is 2 plus a square root of 5 times 2 minus a square root of 5. Then it's using conjugate identity. You have 4 minus 5, which is minus 1, and it is exactly this. But remember, finding m and n just by try and error, it is a very difficult job. But thanks to this formula, you can now find x1 and x2 and find m and n from x1 and x2. As a matter of fact, m is minus x1 and n is minus x2. This is just for your information. You don't need to know it. Okay, let me give you another example. Next example. If it is possible, factor this one, plus 3x plus 10. The good thing about this is, if it is not possible to factor from the beginning, you say that, okay, it is not factorizable, and you stop. A is equal to 2, b is equal to 3, c is equal to 10, and then find delta, b squared minus 4ac. b squared minus 4ac will be 9, 3 to the power of 2, minus 4ac. ac is 20 times 4 ad minus ad. So ad, 9 minus ad, it is 71 with the negative in front, which is negative, right? Therefore, no roots, therefore no factorization. It means that I cannot factor this quadratic at all, and I have to leave it as it is. So next time I will talk about more aspects of quadratics. Till then, stay safe and see you. Bye-bye.